All right, the next the next problem we're going to do is problem number 4. All right, so let's take a look at number 4. All right, with example 4, you have f of x equaling the square root of 4 minus x squared. All right, so the domain issue here is that this part under the radical is going to need to be bigger than or equal to 0. So you need that. I'm investigating domain. So that needs to be bigger than or equal to 0. Okay, now when you're doing quadratic inequalities, it can be a little tricky. So I think it's easier to think of it intuitively. So let's just think about what causes that to equal 0. You see how it would really be putting in a 2 or a negative 2 right there? Okay, or you can solve that, the equal one, by putting in, by solving for the x. So subtract the 4, divide the negative 1 out, and then take the square root of both sides, and you wind up getting a positive or negative 2. All right, now that's what causes it to equal 0. And look, it's usually okay to equal 0. Okay, so it's normally okay to equal 0 under a square root. You just get 0. All right, so as far as the function goes, you're allowed to be equal to 0. Okay, now what you've got to test is this. Okay, so to solve a quadratic inequality, it's not as easy as you think. You need to find those values, and then you need to test here, here, here. Okay, so if you plug in a 0 for x, you're good. Okay, so that turns out good. This is fine. Okay, but when you plug in like a 3 for the x, do you see what's going to happen if we put a 3 in there? You'll get 4 minus 9 under the radical, so you get a negative number. So you don't get anything when you're past 2. And for a similar reason, if you put in a negative 3 right there, aren't you still going to get a 9? 4 minus 9 would still be negative, so you're not going to have anything here. So the domain is going to be in between those two. The domain is going to be from negative 2 to 2, including the endpoints. Okay. All right, so that's the domain. All right, now let's go ahead and recall then what happens. Oh, we could do symmetry on this one if you wanted to, because see the squared right there? And notice how we got the same value, whether we plugged in a positive or a negative. If I did f of negative x, this is an exploration of the symmetry. If you want to do that, you can. If you put in a negative x for the x, don't you wind up with the same thing? Because you'll square it and get an x squared, and then you'll still have 4 minus x squared. So that's equal to f of x. So this is going to have y-axis symmetry. Okay, it's going to be symmetric about the y-axis. All right, now's when we normally go in and we do the derivatives. Okay, so first derivative, we did it on the earlier video, and then let me bring the second derivative up. Okay, and I've got those written down right here. When we did the first derivative, we got negative x over 4 minus x squared. And when we did the second derivative, that one was a little harder to simplify, I felt like. We got a negative 4 over 4 minus x squared raised to the 3/2 power. And this one is 4 minus x squared under the radical, okay, still, or raised to the 1/2 power. Okay. All right. All right, so we're looking for the critical numbers. So that's going to be what causes f prime of x to equal 0, or what causes f prime of x to be undefined. So if you look at this, you have the 4 minus x squared in the denominator. So f prime of x is going to be undefined when, and we can just do it by inspection, x equals, is going to be undefined when your number that you plug in here is bigger than 2 or less than negative 2. So when x is bigger than 2 or when x is less than negative 2. Okay, that's when it's undefined. Okay, so x and your domain already earlier on f limited you to being just between negative 2 and 2. What this basically does is rules out the endpoints. So x can't be negative 2 or 2. Okay, the critical values. Let me put it this way. Negative 2 or 2 are not places where you can do the derivative. Let me say that. Okay. All right, because the derivative would be undefined there. Okay, and we're going to find out in a minute why that happens. You might already have an idea. The square root, it stops. See how it stops there? So, for a limit to exist, for a derivative to exist, the limit from the right and the limit from the left have to be equal. And so you're going to wind up having a situation that it doesn't exist because you only got it on one side there. All right, now f prime of x would equal 0 when negative x equals 0. So that means when x equals 0. Okay, so let's think about that. So we know our function is only going to be defined in between these two. Okay. The f itself is only going to be defined when you're in between those two. And then we know here at 0, we have a possible max value. Okay. And we also need to watch out about these spots right here because that's a spot where the function is undefined. So we have to watch out for here, here, and here. We could have possible maxes or mins at those locations. Okay. Okay. All right. So now when we check the sign of f prime, so we're checking this right here. If we plug in a -1, then we're going to be positive on top and we're going to be positive on the bottom. Okay. And when we put in a +1, we're going to be negative on top and positive on the bottom. So negative there. So what that means is it's going to be going up and then it's going to be going down. Remember, not necessarily nice and constant like that, not with a nice straight line slope. But what that helps us see is that right here, we're going to have a max. Okay. And when you plug in a 0 into the f function, we need to see what we get when we plug in a 0, because that's going to be the maximum value. 0 what? Okay, so the f function was just, remember, the f function was just the square root of 4 minus x squared. So when you plug in 0, you get 2. Not plus or minus 2, just 2. So 0, 2 is a max. Okay. All right, now you do have to worry about the endpoints because that's a place where maxes or mins could happen. Okay, so we'll double check those as well. When you plug in a -2, we're going to plug a -2 into our original function and see like where that's going to be. Okay, see what the value turns out to be. And when we do, see how when you plug in a -2, you get 0. And when you plug in a +2, you get 0. All right, so those are going to actually turn out to be minimum spots on the graph. Okay. All right, now let's go over here to f double prime. So when we go over to f double prime, and we want to look for where it is equal to 0 and also where it's undefined, okay, we find out that it never is 0. Okay, it never is 0. So f prime of x never is 0. So what that tells you is you have no inflection points, because those would be the possible inflection points. Okay. All right. And then when you think about what happens when you pick numbers that are between the -2 and 2, okay? So when you pick a number, now we're not seeing what causes it to equal 0. We're seeing what happens when I plug a 0 in to f double prime. And when I plug in a 0 into f double prime, see how that denominator would become 4? I'd do the square root of it, which would be 2, and then I'd cube it, okay? And I could work all that out. I really don't need the whole thing worked out. I just need to know positives or negatives. Put a 0 in there, I get a positive. Square root would be positive. Cube it would be positive. But on top, we have a negative. Okay, so that means it's going to be negative there. And that's going to be what happens completely in between those two. So that means this thing should be concave down everywhere. Okay. All right, so we pretty much have everything we need, because we actually have this is a max, but it's also a y-intercept, isn't it? Because the x is 0, so there can't be any others of those. And then the original function is defined at -2 and 2, and the y-coordinate is 0. Those are x-intercepts, so we don't have to do some additional work. We already have them. Okay. Okay. All right, so basically you might already recognize this one. Okay, so it's going to have 0, 2, -2, 0, that. So the f function had to be increasing until it got there, and then decreasing, and everything had to be concave down. So it's just going to be that. Turns out to be the top half of the circle. Okay, and it is a dot on the -2 and the 2. Okay, those are part of f. Okay, but you can see why you don't have a derivative there for a couple reasons. See how that's a vertical tangent line right there? Okay, so the derivative, the slope would be undefined, or it stops. So if you thought of it in terms of limits, you don't have a two-sided limit either. Okay. All right. So you have no minimums. This is a absolute maximum. Okay. And then this is an absolute minimum. And it's shared by that one as well. This is a relative and absolute max. Okay. And remember, you can have your absolute mins, and all can happen at those endpoints. Okay. You don't call them relative, though. They're the absolute. All right. So that's example 4. All right. I'll post this one.